started talking about vectors with just a little bit more like added in. So we took some intervals of them, and then we also started looking at like what it means to be velocity, acceleration, speed of a vector, which we said is very similar really to a lot of our other stuff. It's just now we have an x component and a y component that we have to take into consideration. So this says the position of a particle at time t is given by r of t equals 2t cubed plus 3t squared times vector I plus t squared minus 12t times vector j. Write an equation for the line that is tangent to the path of the particle at the point where t equals 1. So what are the things that we need in order to write the equation of a line? Just in general. Slope and a point, right? Okay. And so what do they give us for our t value? 1, right? And remember that our vector is technically broken up into what and what?
Horizontal and vertical.
Correct, which we represent with?
I and J.
The other one. What do we tend to represent as our horizontal stuff?
Oh, X.
Correct. What do we tend to represent as our vertical stuff? Y, which then also happen to be the two things that we need to write a point. Yes? So we basically have our equation there that we need to write a point for our point. We just need to plug in what?
1.
So 1. So r of 1, okay, so 1 cubed is 1 times 2 is 2 plus, it's going to be 3, we get 5, comma, we plug it in for our y component, what do we get there? Negative 11. Yes, no negative. So we have the first part that we need, right? Y plus 11 equals something times x minus 5. Yes? But now what are we missing? The slope. Which, for the position of a particle, is going to be the what? The derivative, which we also call our velocity. Yes? Okay. So, to find v of t, what do? Take the derivative of what? Yeah, but like how many things do I have in R2? 2, right? I have to take the derivative of each component. Okay? So what's the derivative of our x component? Okay, what's the derivative of our y component? Yeah, okay with that. And again, we're specifically wanting the velocity or derivative at 1. So we get okay, comma. Okay, which is my velocity vector. How do we find slope? What is slope? Think back to like pre-algebra days. What is slope? Not just the y over x, but like what about the y? The change in y over the change in x. Yes? Well, velocity, again, is my rate or my change in stuff. Yes? And I have it broken down into 2 components. Yes? So basically, this is my change in x, and this is my change in y. Agreed? So if I wanted to find the derivative, or sorry, the slope to plug in there, what do we need to do? Correct. So very similar to what we have done in the past with these. The only difference is we have to kind of switch our thinking that our x stuff and our y stuff are now separate. So how do I translate that back to what do we need it to be? So then part B asks us, find the coordinates of each point where the horizontal component of the velocity is 0. So what is our horizontal component of our velocity? Of the velocity, right? So that one. And I want to know where that is what? Okay. So what would I do to solve for that? Factor out not just a t but a 60. And we're left with? So we get, can t be -1? No. So we're looking at t equals 0, yes? But does it ask us for the time at which that happens? Well, it asks us for the what? Yeah, but it's more importantly it asks us for the point, right? So like I need to then plug that back into what? If I plug in 0, what do we get for r? We get 0, 0. So at the origin, our velocity is 0.
That's normal.
What questions do we have there? Projectile motion. Yeah. So some of y'all might have seen stuff that looks like this before. Some of y'all might not have. That's okay. So it says a projectile with a mass m launched from an initial position r sub 0 and having an initial velocity of v sub 0 has a position vector of r of t equals -1/2 g t squared times our j vector plus t v sub 0 plus r sub 0. Likewise, the path of a projectile launched from an initial height h and an angle of elevation theta, neglecting any air resistance, is described by the vector function v of t equals v naught cosine of t times I plus all of that stuff times j. Yes, no, maybe so. So again, when we're looking at our projectile motion, if we're looking for this second equation, this can be helpful because then we can break it down into horizontal motion and vertical motion instead of having both of them together, which is like what a lot of our traditional equations do. So it says, at a recent Civil War reenactment, a cannon charge was fired from ground level at a 60-degree angle of elevation and an initial speed of 300 feet per second. Find the following. So, a parametric equation for the cannonball's trajectory. So, what do we need to look at for a parametric? Parametrics have in. What makes a parametric equation different than our other equations? There's an equation for an x and an equation for a y, yeah? Which basically they've given us here, they just gave it to us in vector form instead of parametric form, right? But I can still let my x b naught cosine of theta times t, and my y is still all of that jazz. Yes? No, maybe. So x is gonna equal, what's our v naught? Our initial velocity. 300? What's our angle? Okay, luckily for you, this is a calculator active question. So you don't have to remember what cosine of 60 is. What is cosine of 60?
I'm in reading.
That is not. Sorry, what? Yeah, 1/2. Times t. So this is just gonna equal 150 times t. Well, if cosine is 1/2 at 60, that means that sine is cool. So, looking at our other parts of this, what is our height that we are lunging it from? 0. That makes our life a little bit easier. Yeah? Okay. We already said that our v naught, I'm going to write that first just because this is negative, so a lot of times we'll switch it. I get 300 times, we said that sine of 60 is going to be square root of 3/2 times t. Agreed? Alright, and then what are we going to get here? What does the G stand for? Oh, okay. Anyone happen to know what gravity is?
How exactly we want to be?
Not very. Negative 32. Yes. So that means that we are, and then we're multiplying it by 1/2. So we would get.
No, because the negative.
The negative's already there, so we don't really have to like take that into account. The negative only tells you direction, right? So we're just plugging in the g value of the actual number, which is 32 feet per second. Are we okay with that? Yes?
I can't do the conversions in my head, so we'll just be like.
32 feet per second?
Yeah.
Oh, because you
I
want
know
it in meters?
Yeah.
I want meters. This is math class, not science class. Sorry.
Are we gonna have to memorize
32.
gravity?
32? Yeah, sure.
But like for the test, are we gonna know it?
Probably. It would be a good thing to know, yeah. So what are we gonna get there? Sorry. I'll leave 1/2 there. Times 32. Yes? T squared. Yes, what maybe? So we would get, this is gonna be 150 square roots of 3 t minus 16 t squared. Or else with that. Alright, then what's part B asking us for?
The maximum height.
Okay? So what do we want to do? Cool. How do I find that? Huh? Correct? Do I have a velocity equation?
Oh, then you gotta find it.
Ah, okay. Wait, what? think about our, just in general, normal maxes and mins, right? How do we find maxes and mins of an equation? Those are where we have a horizontal asymptote, which means that our derivative or slope is 0. Are y'all with me there? And again, it is kind of hard to wrap our heads around that, but like technically for an for an instant, we have stopped moving. Or when our derivative is 0 for an instant, we have stopped moving. Are we all okay with that? That's what our derivative equaling 0 means. It means we are at rest. Alright, so anyway, going back, we said that we needed the what equation?
The y equation.
We need the velocity equation, but we only need the velocity equation for the y value, right? So we only have to use that second one to find my dy dt.
Yeah.
So
Okay, that's what I was getting confused at. I was
That's
like, why?
like-
I was
it's
like,
not
it's
gonna
not gonna
change
stop.
no, which is like only your x
Okay,
motion
okay,
has
okay.
stopped. Yeah. So I'm only considering only my y motion has stopped. That's why I'm only considering the y equation. So what would my derivative there be? So y equals square root of the 3, sorry. Just a bad 3. Minus. Okay, and we are in solving for. Okay. And again, this is calculator active, so at this point, when we solve, we're gonna plug that in. So we get that t equals 100 and negative 150 square root of 3 divided by negative 32.
It's
8.119. And we are in seconds. Okay, is that my answer? Because we actually want the height, right? So that's the time that I'm reaching my maximum height, which is why then I said we're going to use our calculus for this, because then now I'm looking at y of 8.119. So we're plugging that back into our y equation. I mean, that's why you have calculus-based physics, because calculus is what allows us to do most physics things.
This is just
For a
so
second
much
I got a
faster.
negative.
Oh yeah, algebra-based physics is not much fun.
Oh,
But
I
not
know,
that I like
I know.
physics all that much to begin with. But if you're gonna do physics, the calculus-based physics is way easier. Alright, what do we get here?
Is it 1,000?
1054?
Well, 1,055. If you want to do
Well, what do we round to in this
Oh.
class?
6, 8, 8.
Okay. That does not change. We still have to round to 3 decimals. Unless it states otherwise, which it does not say round to the nearest one. Okay? Are we okay with that?
Yes.
Cool. Then next time it asks us for the horizontal distance traveled by the cannonball. What would that ask me?
Well, we already have time.
Well, that time is when we're at our maximum height, right?
Oh wait, you're right.
It's
So,
asking for the total horizontal distance traveled by the cannonball.
so we just double it.
Yeah.
Yes.
Because if that's where
There's no
it's
error.
peaked, then it's like symmetric.
Yeah.
Correct. So, if I didn't have part B, how would I do it?
Oh.
Okay, cannonball hit ground, right? That's when the
It
horizontal
stopped.
distance has stopped.
It stops moving.
Ground equal 0, right? And that would be our what? That is where y equals 0, right? So then we would set our y equation equal to 0. Well, 0 is one of your options, right? Because you're starting at a height of 0, right? You need the other one, because it's quadratic, so you're going to get 2 solutions. Right? So like notice here for my y equation, I can factor out a t.
Wait. Why am I screwing up?
Yes, no, maybe? Are y'all with me there? If I say that equals 0, I don't care about when the t equals 0. I really only care about where my second one equals 0.
Oh, yeah, okay.
Right? Because again, it's starting at 0, it's landing at 0. It is a parabola-like shape. It's going to have 2 roots. Okay, but we don't want to know the original one because it traveled 0 at 0, so that's not helpful. So we get t equals negative 150 square roots of 3 divided by negative 16. 16.238. And then we're looking for what of that?
The X.
Right. So then you're plugging in. And so yes, we should get 2,435.6. Which yes, is like gonna be roughly double that. Well, because we also took a while on that work. Yeah, so for our speed equation, you would just plug into your speed equation. So.